Rectangular fence is to be constructed. The area is 200 square meters. We have a length, we have a width. We know the area is 200. Okay. The length costs $3 per meter. And the width is $2 per meter. Find the length that will minimize the cost. When you're doing max-min problems, the first thing to do is get an expression for the quantity to be maximized or minimized. That's the cost. The cost is equal to, well, the cost of this side would be 3 times L. The cost of this side would be another 3 times L. We get 6L plus. We have 2W and another 2W. 4W. That's our cost function.
So 6x plus 4y.
We could do 6x plus 4y. I don't care.
So see, the thing is, you wrote the length, x length, and y equals.
Oh, I said that. Well, there you go. And then this is the cost function in terms of x and y. I asked for it in terms of x and y. So 6x plus 4y is absolutely correct. Okay? Now, what we must do is get that expression for cost in terms of a single variable. How do you do such a thing? Well, we have to use a constraint. What do we know? We know that xy is equal to 200. That enables us to solve for one of the variables in terms of the other. And I'm asking for the cost in terms of x, therefore let's eliminate y. Y is 200 over x. Therefore, the cost function in terms of x is 6x plus 4y, which would be 800 over y, 800 over x. Okay? 4 times y. That's the cost function in terms of y. Ah, gee whiz. That's the cost function in terms of x. Okay? Sorry. All right. Everybody else set on that? Now we have the cost in terms of a single variable. Next thing is to find a critical value. What about endpoints here? There is no real endpoints. X has to be greater than 0, but x can't be 0, so there are no real endpoints for here. There just can't be negative values. Take the derivative.
Wait, why are we looking at x is greater than 0?
Because x can't be negative or 0. So I'm just making sure that we don't get a negative answer or a 0 answer. It's always good to have some, endpoint considerations here. Bless you. All right, let's take the derivative, dc dx. Derivative 6x is 6. The derivative of 800 over x is minus 800 over x squared. And we want to set that equal to 0. Multiply both sides by x squared. Let's solve for x. Let's add 800 and divide by 6. Okay. That will give us 400 thirds. X, therefore, is the square root of 400 thirds. What's that?
I thought it would be x cubed.
Because I got that, I didn't think it was right.
It's right.
So x
So
is
x squared.
400 over 3.
X is the square root of 400 over 3. And square root of 400 is 20.
You have to raise it up a little bit.
So you have square root of 400, which is 20, and the square root of 3, square root of 3. You could wait, did you guys have this? I don't think anybody had that. Did you have this, John? Oh, you had, okay. I'm not sure in the test if I'm going to leave it like this, or I may have it rationalized. Okay, either way. The y value, by the way, is 200 over x, which would be 200 over x, which in this case, I'm going to use the 20 over the square root of 3. Okay, that's x. And what do you get here? The square root of 3 comes up top, You get 10 square roots of 3. Okay, when you simplify all this. So x is 20 square roots of 3 over 3. The y would be 10 square roots of 3. Okay?
Why do we need y?
We probably don't. What do I ask you for? I ask you find the critical value of x. This is the critical value. It's where the derivative is equal to 0. Find the minimum cost. Well, let's find the minimum cost.
So we don't need the y?
Well, we could put it back in here and use the x and y, or we could use just the x and put it back in here. We don't really need the y. The minimum cost is equal to 6 times x plus 4 times y. That's this, so that'd be 40 square roots of 3. The minimum cost is 80 square roots of 3. Okay, this is 40 square roots of 3, this is a 40 square roots of 3. The minimum cost is 80 square roots of 3.
Move it over.
Okay? There you go.
Okay, so that's the minimum y value.
No, that is the minimum
That's
cost.
the cost. I'm
Okay.
talking about the one before where I was kind of confused why we needed the y.
Okay. Yeah, I used the y value in there. I used this 4y.
So if you said find the critical value of y, that would be 10 square roots of 3?
Yes, it would.
How is that 40 square roots of
This here,
3? Yeah.
3 goes into 6 2 times. 2 times 20 is 40.
Oh.
Okay?
Yes, yes, good.
That's going to be your test. Your test will be very similar to this. That's what it's going to look like.
Sweet.
Here's that. Here's this. Let's take a look at your lab.
You already posted it, right?
Yes.
Where'd you post it?
It's in my drop